In this example, we're going to look at transient material balances. And the system is we have a tank that contains a sugar solution. So this is 850 kilograms in the tank, and it's water with 5 weight% sugar. And then what we're doing is we're adding into the tank a concentrated sugar solution. So the mass flow rate in is 20 kilograms per minute. And this solution has 45 weight% sugar. And what we want to determine is how long it takes before we get to a concentration of 15% sugar in the tank. So the stopping point is 15 weight% sugar in the tank. So what we're going to do is write down material balances, mass balances. The total mass in the tank changes with time because we're adding 20 kilograms per minute. And then this differential equation has initial conditions that when T is 0, the mass is 850 kilograms. And then we do the same thing for the sugar. Mass of sugar in the tank as a function of time. Flowing in 20 kilograms per minute, and the weight fraction that sugar is 4.5. And at the start, the mass of sugar is 850 times 0.05, 5 weight%. So these are easy differential equations to solve, but they demonstrate the idea for more complicated transient balances. Now, I should point out that the tank is well mixed, so the concentration is uniform as we had. So essentially, we have in the tank a stirrer that's mixing up the solution. So if we look at first the overall mass balance change in the mass in the tank, it's 20. Well, this is simple to integrate from 0 to some time t, where the mass at 0 is 850, and we're interested in the mass at some time t. So mass minus 850 on the left side equals 20 times t minus 0 on the right side. And likewise for the mass balance on the sugar, this is 9. And doing the exact same type calculation of integrating from 0 to time t, the starting mass, this is 42.5. So that's the starting mass, and the mass of sugar at a later time. So mass of sugar is equal to 9 times t minus 0. Well, we're interested in the mass fraction of sugar at a later time. And so the mass fraction of sugar at any given time is going to be mass of sugar over the total mass. Mass of sugar is 42.5 plus 9 times t. And the mass total is 850 plus 20 times t. And what we're interested in is when this number is 0.15. So we can solve that. We can just do the algebra solve for t. Let me pause and rearrange that. And then I can put terms with t, 9 minus 3, t on the left, and 127.5 minus 42.5. So we can solve for t, 14.2, and probably significant figures. We call this 14 minutes. So how long we have to flow this concentrated solution to get up 15% in the tank.